All right, so next set of notes is on relative and absolute extrema, and we've been talking in class about relative basically is what you can see. Absolute means as long as you can include the endpoints, if it starts here, stops here, there will be an absolute and an absolute maximum and absolute minimum. However, it does need to be pointed out that if you don't include the endpoints, and it happens to be the highest or the lowest point, you may not have an absolute if it's not included, if that's not included in your interval. All right, let's go ahead and see what we're talking about. The extreme value theorem. If the function is continuous on a closed interval, then f has both a maximum and a minimum and a maximum on a closed interval. And notice right here, that's what we're talking about. A endpoint is included, B endpoint is included, but not necessarily if it's an open circle, or excuse me, parentheses around it. Critical values occur where the first derivative equals 0. Sorry, it's a typo. Or is undefined. Okay, that's a typo. It should be equals 0. How do we find critical numbers? Critical numbers are possible max or min locations. Okay? All right. Solving for max and min step by step. We're going to set the derivative equal to 0. Does that sound familiar? Because if you come up to a high point, don't you slope off to be a 0 slope? And if you come down and then turn back up, that minimum would also slope to the 0 point. So where I was actually, it's like taking Rawls' theorem and pushing it now to extreme values. All right, so we're going to set the derivative equal to 0 and solve for x. This will only tell you the critical values to check. I may have 5 critical values, but there can only be one highest and lowest point, right? Only 2 of them may apply, but at least I know what numbers to check. Put the critical values on a number line. Okay, it's important because if you have, as you're working the problems, when you get your critical values, let's just say a critical value is at 1. I may not know, because I might not know what that graph looks like. I may not know if 1 is a low point or a high point. But I'm going to check to see what's happening to the slope on the left of it and to the slope on the right of it. So I'm going to think about it, what it looks like on a number line. Find the relative extrema by testing points between. For a value to be a max or a min, the sign of the function has to change from positive to negative or vice versa, and we'll do that. Plug the x's back into the original function to get the y values. We'll do that too. And if it's a closed interval, plug endpoints back into the original function. All right, let's see if we can find relative extrema of the function x squared minus 3x plus 2. Does that look familiar? Yeah. Didn't we just do this one? Yeah. Okay, this time it says relative extrema. Okay. We actually do know a little bit about this because we do know if we take what? Take the first derivative, 2x minus 3, all right, and set it equal to 0. We know that what? X is equal to x is equal to 1.5. Do we already know this is a minimum or maximum? Minimum. We actually ended with this example problem in the Rawls theorem. We know this is a parabola. So we do know that this is going to be a relative minimum. But let me talk to you about when I say a number line. We don't really know. Let's just say this is a problem that we don't know. I do know that 1.5 falls between what? 1 and 2. Correct? If I did not know what that graph already looked like, I want to say, well, let's put 1 back into the original function. No, I'm sorry. Put 1 back into the derivative because I'm interested in the slope, right? What's the slope of all of the points coming down? All of the tangent lines. What happened to the slope right here? They're negative slopes, aren't they? What's happening to the slopes over here? Positive slopes. So when I transition from a negative slope to a positive slope, that's a relative minimum, right? What if I transition from a positive slope to a negative slope? It's a relative maximum. So that's what I want to check. So what we're going to do is we're going to take a number line and we're going to put 1 back in here. What's 2 times 1 minus 3? That would be negative, right? Put 2 into here, to your first derivative. Be 4 minus 3, which is 1, which is positive. So I have a decreasing slope which is with negative sign, to a what? Increasing slope. And so I know I have a relative minimum. So we have a relative minimum at x equals 3/2. We did already realize that. We just had worked with the equation. Okay? Does everybody understand the sign line? Take your critical value, check points to the left, check points to the right, see if the sign changes. All right. All we have now is you have all the information. All I've given you now is we got several different kinds of examples. All right, let's do number 2. Anybody know how many times it could turn if you've got an x to the third? It could turn a couple, 2 or 3 times, right? Does it change direction 3 times? 1, 2, 3.
Change direction 3 times.
Change direction 3 times. But it would have a high point and a what? Low point. Okay, I'm thinking 1, 2, 3. Okay, so I'm probably looking for a relative maximum and a relative minimum. I could have both. Is everybody good? All right, so what do I do first? Take a look at your steps. Take the derivative of your function. So, take the derivative of my function f. Now what? Set it equal to 0. I'm going to factor out 6. Oh, made it a lot easier, didn't it? Do I have points to check? Did y'all get -1 and -2? Okay. Do I know yet what these are? No. Okay. I just know right now that these are what? Critical values that need to be checked. Everybody good? All right. Now we're going to go to a number line. We're going to go to what we call a sign line. I'm going to put -1. Let's put -2 and -1. And that's pretty much all I need. But I'm not going to check -2. I'm not going to check -1 because I know that the slopes at those points is 0. Right? Now I do want to know, does it increase or decrease? There's 2 ways you can do it. Okay? I can imagine putting a number, I need to put a number over here. So what's the left-hand side of -2? Like -3? Now, just don't write anything yet. Think of it with me. I want you to look at this with me. I can either put -3 into the original derivative, which has a lot of big numbers in it, right? -3 squares of 9 times 6 is 54. I have a lot of, or I could put it down here. Everybody good? I am going to do this. I'm going to say, well, what if I put it into the x plus 2 factor? And what if I put it into the x plus 1 factor? Do that for me. Jot those 2 things down. Instead of putting it into the big equation, we're going to put it into the factored form of the equation. It will still work. Okay? Everybody okay? So far, so good? Now, instead of putting -3 into the big equation that's going to have a lot of bigger numbers, let's put -3 into this equation. What happens if I put -3 plus 2? Negative, positive? Negative. So it's negative. What about numbers in between -3 to -2? Aren't they all negative, 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 negative? Everybody good? All right. What if I put numbers bigger than -2, which is like negative what? 1.5? What if I put -1.5 plus 2? Positive or negative is all I'm interested in. Positive. So when I go in here, it's positive. Everybody good? Now, let's put a number in here bigger than -1. I'm going to try the easy 0, right? What's 0 plus 2? All I care about is positive or negative. Positive. Everybody understand? Everybody good? I'm getting ready to put it in the other one too. Okay? Now, let's do the same thing. We're going to put it into the other factor. What's -3 plus 1? It's negative. And then in between, it's also always going to be what? So if I had negative 2.1, negative 2.2, negative 2.3, negative 2.4, negative 2.5, it's going to be negative, negative, negative until I get to the line. Everybody good? What about between negative 2 and negative 1? What about negative 1.9? It's still what? It's still negative, isn't it? Then what? What happens when I get to negative 1? Go beyond it. What's 0 plus 1? Or even like, negative 0.9, 0.8, negative 0.7, negative 0.6. It's going to finally become what? Okay. Let's just add them up. Let's multiply them. What's a negative times a negative? Positive. If it has positive overall slope, right? A negative slope times a negative slope would make a positive overall slope. So this means that it is what? Increasing. Everybody good? Okay, what's a negative times a positive? Negative. So this tells me it's what? Has a decreasing slope. So far, so good? Now, what's a positive times a positive? It's positive. So that tells me it is a increasing slope again. Everybody okay? Now, let me show you something. Grab a calculator. Somebody, you got a calculator? All right. I did the factored forms of the factored form, the easy form. Now, really, did I have to worry about the 6? The 6 didn't change anything. It's a constant 6. It wouldn't make any positive number becomes negative, so I didn't even have to worry about the 6. The x plus 2 and the x plus 1 were my factors. Then it would matter. But the negative, and I would have had a negative, 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 negative. Actually, I had a teacher who did this, and she went, what? 6 is always what? 6 is always positive. I should have done that. 6 is a factor, so if you did have a negative 6, it would have an impact. Does everybody understand? Okay, so it'd be like positive times negative would be still positive. Okay. I know the 6 is not going to be a factor, so take, what's negative 3 squared? 9 plus negative 3 times 3 would be what? Negative 9 plus 2 is what? Positive 2. I would have gotten positive had I put a negative 3 into the original function, right? Does everybody understand? Would I have gotten positive if I'd put negative 3 into this function? Does everybody see that?
Doing all that extra, yeah.
If you think it would, you're welcome to do it that way. Okay. Only reason I do it this way is because it's a lot easier for me to say what's negative 1 point. So when you do negative, if you don't have a calculator and you have negative 1.5, what's negative 1.5 squared? Plus 3 times negative 1.5 plus 2. You see what I mean? It gets a little trickier. I can do this in my head quick, but it amounts to the same thing. Okay? So a lot of teachers have taught their students to break it down, so I'm going to pass that way on to you. I'm using the factored form. I'm using all the factors instead of the original equation.
So if we didn't do that, you could just plug the numbers in.
If you have your calculator at home and you want to do it, you can plug it in. So if you put in, grab your calculator and just check it and see if I'm right. All I need to know is if it's positive or negative. I don't really care what the number is. Grab your calculators. Okay. I believe that I could do a sign line with my factors, and I believe I could have it on there, positive or negative, before you could get them all typed in. Okay? So, okay, let's just do one. Ready? All right, do you want to do the 6 times this? All right, here we go. Negative 1.5 squared. Make sure you put parentheses about negative 1.5. Okay? Plus 3 times negative 1.5. Plus 2. It should be a negative number. Is it negative? All right. Now, take 0. That one's easy. 0 plus 2 is positive 2. Okay. I will not stand in your way, Jenny, or anyone. If you would prefer to plug your numbers on your sign line in here, on your number line in here, this is called a sign line. This method up here is the sign line. I'm simply breaking it down into factors, and I'm taking into account what all the factors measure up to be. Okay? Okay. All right. Have we figured out yet? Do we know the relative extrema? Hey, if it increases and decreases, what's happening? Increases till it gets to here, decreases here, then what? Then it increases again. So we have a what? Relative max at what? X equals -2, and we have a relative what? Minimum at X equals -1. Whoa, whoa, whoa. That's true, but what if it wants the points? We need the points. So, right. So this is, I want the points now. I know we're on the number line, but how far up, wide does it go, and how far down does it go? So I'm going to have to put -2 where? The original equation. What's -2 cubed? -8 times 2 is 16. And -2 squared is 4. Times 9 is what? 32? 36? 36? I'm plugging -2 into the original function. I need to know where the point is on the graph. I'm not worried about the slope anymore. I'm trying to figure out where it is on the graph. You got calculators. You do it quicker than me. Okay. So it's what? -40 plus 47, 7. So that's -2 comma 7. So it does go as high as 7. All right. How low does it go? But -1. I got 6.
I'm gonna do it in my calculator.
Did you get? Anybody get 6?
That was in my head, though.
What?
Oh, she's surprised.
Okay. So let's go back and review our steps. Okay. I know when you first saw these, you're like, oh my God, that sounds massive. Did we set the derivative equal to 0 and solve for x? In this case, we had to factor a quadratic, and it did factor pretty easy. I got 2 critical values. This will give you critical values to check. All right. Put the critical values on a number line. Did we do that? Okay. And I actually included a sign line. What I call a sign line. First time I saw it, I'm like, what in the world is she doing? And as I watched her work a few examples, this is the teacher I went to, I'm like, oh my God, it's so much easier. To me, it's easier, but I will not stand in your way. All they're doing is, all you need to do is find out is it increasing or decreasing to the left and to the right of your number. So you can go back to the original derivative, or you can do the factored form of your derivative. All right, find the relative extrema by testing points between the critical values. That's what we did. Increasing or decreasing to find its max or min. Plug x's back into the original function to get the y values. Did we do that? So we did the last one. If it's a closed interval, which we haven't done one yet. Okay. Find the relative extrema of this one. This is still a cubic function, isn't it? All right. In the interest of time, we're moving on. Okay.
So, wait, what are we going to have those little tests?
You probably will have one, yeah.
But we don't have to do it.
Yeah, you will. You're going to work on it tonight. You're going to come to see me for questions on either Wednesday morning or Thursday morning. Donuts again. Oh, my gosh.
All right, so.
Panthers is almost over there. Isn't their regular season over?
Now the real milk.
I tell you what, I'll take a donation and I'll go pick them up. But for some people, I thought maybe 1 dozen, that would be 1 apiece. But I brought 3 dozen or 2 dozen, and some people only ate 1 and other people ate more. And then I worried that I had given you too much of a sugar rush, that you would be like dead the rest of the day. Okay. Let's do one Find the absolute extrema of the function x squared on negative 1 to 2.
So we just skip.
We skip 3 only because 3 is very, very similar to 2 because it's cubic. This is also cubic, so you would be repeating these steps. Okay? All right. You may tell you the answer so you can go back and check. Oh, we do need to do that one. Let's. All right. Let's do it. Step 1. We're going to do example 3. I did include it for a reason. 3x squared minus what? 6x plus 3. Set it equal to 0. I'm going to factor out a 3. Uh-oh, what happens? So I only have what? One.
One critical value to test.
There you go. Very nice. That was awesome.
Wow, we rolled.
So, this is easy. So my number is 1. So if I do my sign line, y'all are going to love this. Or maybe not. All right. I'm going to pick 0 and what? 2. All right. I'm going to do 3. I'm going to do x minus 1, and I'm going to do x minus 1. You have to include them even though they're the same. You do yours on your way. I'll do mine my way. So put 0. This is too easy, though. What's 0 into the original one? Positive or negative? Yes, 0 into the original derivative is positive 3. All I care about is that it's positive. Oh my gosh. Now, if I did it through my way, which this one's too easy, but if I did it my way, would I get 0, would I get negative, 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 negative? But positive times negative would still be positive, so this is what? Increasing in the interval behind negative 1. Everybody good? All right. What happens, though, to the right of 1 when I put a number bigger than 1? 1 minus 1 is positive, positive, and then this one's still positive. Uh-oh, what happens? It's also increasing, isn't it?
Yeah.
Mm-hmm. What about a number bigger than 2? Okay. If that number's bigger than 2, everything's positive. Oh my goodness. What does this mean? It's increasing at 0. It's increasing still between 1 and 2. It's increasing everywhere. It does have a turning point, but it doesn't actually form a hill or a valley. So this is going to kind of look like that. Do I understand? So this one has what? No.
Absolute.
Well, we're doing relative.
Relative. Extrema.
Yeah. Okay. Again, this only tells us points to do what? Points to check. Okay. In this case, when I checked, I ended up with positive, positive, positive. It is turning a little. It's just not turning enough to form a hill or a valley. Does everybody understand? Okay, so it's good to be able to interpret your data when you get it. That's why I had that included. All right, find the extreme on a closed interval. So this was too easy. 2x is equal to 0. X is equal to 0. I have what? One critical value to check. But this time I'm looking for what? Absolute extrema. So that means if I include, notice that there's a bracket there, I have to include negative 1 and include what? Positive 2. So also include endpoints. That's the difference between relative and absolute. So I have what? Also x is equal to negative 1 and x is equal to positive 2. I don't really need to worry about the sign line Because I can calculate exact points. So I'm going to say at x equals 0, my point is what? 0 comma what? So what's 0? 0. All right, at x equals -1, what's -1 squared? Positive 1. And at x equals +2, it's going to go up to, I'm going back to the original equation, I'm going up to what? 4. What's my highest and lowest point? Okay, how high does it go? It goes as high as 4. So this is my what? Absolute maximum. Okay, now which one of these is the lowest point that I ever get to? 0, 0. So even though -1, 1 was a possibility, it does not meet either criteria. So this right here is my what? Absolute min.
I like that better.
Okay. I mean, what I've done from here on is I've tried to give you examples of different ones. I will post solutions to the rest of the notes so that you can see them, since we didn't get to finish all of them. The process doesn't change, but the examples do change.
See, I probably won't
So
be
we got
able to do
these
my
in the
homework
homework.
Yeah.
because
Well, you got evens, and then you've got the 9 on extreme.